section is 12.3, which is modeling linear systems. So this is actually our last section of the module, and then also our last section of the unit. So it definitely is not necessarily new. It's more of kind of applying what we've learned in a different way. So it shouldn't seem completely foreign. So what we're going to be doing is setting up linear systems of equations or inequalities from a scenario. So the first one we're going to look at is linear equations. So we have Taylor is going to buy coffee and hot chocolate for first period. Coffee costs $2.25 per cup. So I'm going to kind of underline as I go things that I think are important. And hot cocoa costs $1.50 per cup. And typically in math, anything that's a number is important. She pays a total of $15.75 for 8 cups. How many of each did she buy? Okay, so first of all, we have two things that we're talking about, coffee and hot chocolate. So I'm going to go ahead and let X equal coffee and Y equal hot chocolate. And I'm just going to abbreviate this, hot cocoa. So we do know that she buys 8 cups of hot chocolate and coffee. We just don't know how many of each. So our first equation could actually just be X plus Y equals 8. So this represents the amount of coffee and hot chocolate is 8 cups. And I know we have practiced something like this. And typically we have one equation for the amount and then the other one for the money or the monetary value. So now we're going to look at the prices. So coffee costs $2.25 per cup. So I'd say $2.25 per cup of coffee. And then we also know that hot chocolate costs $1.50. So then we have plus $1.50 per cup of hot cocoa. And this should all equal the $15.75 that she spent. So that was the hard part, is setting up the equations, because typically that part is already done for us. So now what we have to do is solve. And this is what we spent most of the unit doing, is solving systems of equations. So this is where you get to pick. If you really are feeling brave, you can graph it. I don't recommend it though, because the numbers aren't great. So then that leaves us with either using substitution or elimination. This one is actually, it could be done with either method. If we did do substitution, it would be pretty easy, because with the first equation, we can solve for y or x pretty quickly. And then we could also do elimination by multiplying the top equation by either 225 or 150. So I personally like elimination, and I have a feeling most of us feel that that method is a little bit easier. So I'm going to choose that one. So we can either multiply by 2.25 or 1.5, depending on what variable we want to eliminate. I'm going to eliminate y. So I'm going to multiply everything by 1.5. Or $1.50 rather. So now that we have this, we're going to go ahead and multiply 150 by x, y, and 8. So this would be 150x plus 150y equals 8 times 150, and 8 times 150 is 12. Then I'm going to go ahead and rewrite my second equation, which I don't need to do anything to. Okay, so from here, now I have my two equations ready to go. So this is where I have to decide what operation. I already know I'm eliminating my y. I just have to decide, am I doing addition or subtraction? So remember, same sign subtraction. These are the same sign, so I am going to subtract. Now, when I subtract, I have to make sure that I subtract each part. So $1.50 minus $2.25, that's going to be negative 0.75. $1.50 minus $1.50 goes away. And then we have, and I forgot my little x, and then I have 12 minus 15.75, which is negative 3.75. Now, to get that x by itself, I'm just going to divide by negative 0.75, And when we do that, we get 5. So remember, the next step is obviously to plug this in, but 5 is not just a number. This is actually standing for the cups of coffee. So I'm going to label this. So we have 5 cups of coffee. Now, if we want to plug it in, we can, right? I can plug it back in, but we can kind of do it mentally. If there's 8 cups of, drinks and 5 of them are coffee, then that means obviously 3 of them are hot cocoa. So that will just kind of save us some time. Okay, so that is modeling with linear systems. This next question is one that's in the book, so I'm going to skip over that. Now we're going to look at modeling with linear equations. So we're actually, and I'll label this too, linear inequalities. So I'm using the one from the book only because with linear inequalities, we have to graph them. And so having the book makes it a lot easier because we have a graph with it. So how we're going to do this is slightly different than how we did the equations, and you'll kind of see as we go. All right, so let's see what we have. We know that it says to write a system of inequalities for the given situation and then graph the system. And then we want to determine if the 0.84 is a solution to the system. So a student has to buy graph paper and printer paper. Printer paper costs $2 a pack, while graphing paper costs $3 a pack. Okay. We also know that she wants to buy at least 6 packs, so that at least is very important. And then she wants to spend at most 27. Okay, so I'm going to set it up the same way that we set up the last one, which was first identifying, well, what's X and what's Y. So we can pick, but also they kind of already set it up. If you look at the graph, the X-axis is printer paper. So I'm going to make X equal printer paper, and then I'm going to make Y equal graph paper. Okay. So I'm going to do my first one just for the amount of paper. So the amount of printer paper plus graph paper. So I know it's something dealing with 6, but it says at least. That means the amount of paper has to be greater than or equal to 6, because it could be 6 or it could be greater than 6. So that's my first inequality. Now from here, I'm going to go ahead and write my next one, which is dealing with the money. So we know that it's $2 for a pack of printer paper plus $3 for a pack of graph paper, and she can spend at most 27. So I know that this will be 27. At most means that she can spend $27 or less. So this has to be a sign like this. Now, a lot of us want to jump to solving this and, multiplying the top equation by 2 or 3. But keep in mind, linear systems, we can't actually solve for a specific point. Remember when we graphed these, there are several different points that make it true, everything in the blob, so to speak. So what we need to do is graph it, and then anything that they have in common in the shaded area is actually the solution. So there's no way to solve this algebraically. The only way to solve it is graphically. So I'm going to go ahead and put these in slope-intercept form. So the y stays the same, the sign stays the same, but I'm going to subtract the x so it's to the other side. Okay, so let's go ahead and graph this. Pay close attention. The book always does weird scales, and they seem to have done that here. So we know that we're going to start at 6, and then the slope is 1 or -1. So if you look at it, I'm going down 1, but I can't go over 1 because that would actually be 1/2 based on this scale. So I have to go down 1 over 1 because it goes by 2s. Then down 1 over 1. Down 1 over 1. And I'm going to kind of just go until I touch the x-axis. So here is our line. I'm making it solid because it's equal to. Now I'm going to do the same thing with this line. So I'm going to go ahead and solve for the y. So I have my 3y is less than or equal to, I'm going to subtract the 2x. So it'd be negative 2x plus 27. And then lastly, I'm going to divide by 3. So this would be y is less than or equal to negative 2/3 x, and this becomes plus 9. So I'm going to go ahead and graph this one. So I start at 9, and then from here I go down 2 over 3. So down 2, and keep in mind this goes by 2. So it would be here, then keep going down 2 over 3, down 2 over 3, down 2 over 3, and then I'll kind of stop there because it doesn't quite fit, so I'll go like something like that. Now we shade. So according to this, the first equation is greater than or equal to, so I'd shade everything above, and the next one is less than or equal to, so I'd shade everything below. So technically, anything in between will make this system work, meaning if she, for example, if I look at the 0.81, she could buy 8 printer papers and 1 graph paper, and she would still buy at least 6 packs, and she would still buy less than $27. So anything in that shaded area will make this equation true. So that's actually how we show our answer. So it says, is 8,4 a solution to the system? So we want to look, where is 8,4? And I'm trying to I made an X. 8,4 is a solution, and the reason why it's a solution is because it's inside the shaded area. Okay, so hopefully that gives you a good idea of what this section is about, and that is it.